Morning. Good morning, students. Warm welcome to today's online session. In this online session, we talk about the architectural design of cloud computing. This topic we will discuss in this session. Topics to be covered in online session are cloud computing architectural design and what are various cloud architectural development layers. Here layers in the sense services, cloud service models, and virtualization support for the cloud computing, and what are various design challenges in the cloud computing. These topics will be discussed in today's online session. Now let us move the basic concepts of cloud architectural designs. Consider the cloud platform design. It is mainly depends on some goals. 4 different goals listed over here. The cloud platform design main goals are scalability, virtualization, efficiency, and reliability. These 4 factors will be considered as major design goals of cloud computing platform. So that means that if a cloud computing platform is available, it can provide some features or some services to the customers or end users like scalability, virtualization, efficiency, and reliability. Now we talk about each and individual goals in detail now. So what is scalability? Scalability is one of the major design goal of cloud computing platform, which can be easily expanded, and by adding more servers or network connectivity accordingly based on the requirement of the cloud computing. So scalability in the sense based on the requirement or demand, there is a facility of adding or there is a facility of improving or enlarging the network connectivity accordingly. So in the cloud architecture, by adding the servers or by adding the network connectivity, so that is called as a scalability. Scalability is nothing but so we can able to add or we can able to increase the capacity of the servers based on the requirement of the customer by adding new servers, by adding new network material to the existing networks. So due to which we can able to maintain the traffic imposed on particular cloud computing technique. So that is nothing but scalability. So sometimes the scalability may increase, sometimes the scalability may decrease. That is called as a scale up and scale down. So the architecture of cloud computing can scale up automatically, can scale down automatically. That can be done basically with the concept of a load balancing. So if load balancing is applicable in that one, the cloud computing technique will automatically scale up or scale down their services based on the demand and supply mode. And the next one is virtualization. What is mean by virtualization? So virtualization is also under goal of cloud platform design. So here virtualization in the sense the control, the administrative control will be maintained by a single point of view in a centralized mode while improving the scalability and workload. So virtualization environment can be set up over the computer with the help of one software that is called as a hypervisor or VMM, virtual manager cloud, virtual machine manager or virtual machine monitor or hypervisor can be used for creating or establishing virtual environment over a client machine, cloud machine. So another important design goal of cloud platform is software reliability. Reliability in the sense flexibility. It can provide the benefits to the cloud architecture in which the data can be put to multiple remote locations over the cloud. We can access the data whenever we require or wherever the require with the help of the cloud computing technique. So we can say that there are various design goals of cloud platform like virtualization, reliability, efficiency, and also another one is scalability. So these four will be considered as a effective cloud computing goals, design goals. Now let us talk about the architectural generic architecture of a cloud. So the generic cloud architecture can be having two uh, ends. One is front end, another one is back end. The architectural of cloud computing can be based on front end and back end section. So here the front end only the clients or the end users or the customers are kept together, and whereas the back end is well maintained by a cloud service provider. So the connection between the front end and back end can be done through one network that is called as a internet connectivity. So with the help of the internet connectivity, the end users may access the data hosted in the cloud whenever they required, wherever they required with the help of the internet only. If you consider the cloud computing architectural, the back end, there are various services. So there are well-known cloud service models. IaaS stands for infrastructure as a service. PaaS stands for platform as a service, and another one is SaaS, software as a service. That means that the cloud computing machine can have some applications that is called as software as a services, infrastructure as a services, and some other services. And here they are maintaining one runtime cloud which can provide the environment for executing cloud softwares over the cloud environment, virtual environment. And the management will maintain all the cloud service models, cloud storage, and runtime cloud over the period of time in the cloud computing technique. And the security is another factor which can provide the security for all cloud softwares, hardwares, and runtime cloud and storage or database clouds for well-known security they are maintaining. Suppose if you observe the architectural general cloud computing architecture, whenever the customer or end user want to access the cloud, he can able to access the hosted data on the cloud with the help of the internet. So whenever the customer wants to host his data over the cloud through internet only, he can able to host the data. So he is having two options: either the end user or client can host the data or can access the data over the cloud or from the cloud whenever he require, wherever he require with the help of the internet. Here, if you see the internet cloud, it is a massive set of clustering of different servers. So the different resources like the space, data, and speed of servers are allocated as per the demand of the clients dynamically. So in general cloud, it is very easy to manage private clouds, whereas public clouds are very easy to access. See, in the sense, if you consider the private versus public clouds are accessed very easily, whereas private clouds are managed very easily. If you consider the trend of the cloud computing development, it is very diagrammatically moved towards hybrid cloud. Why? Because hybrid clouds provides the services beyond the boundary of internet, like it can combine both the services of the so public cloud as well as a private cloud. So we must create public clouds and private clouds over the period of time to access the data, to host the data whenever we require or wherever we require. So security is also becomes the one of the critical issue in safeguarding the operations in the cloud which can be provided. So it seems to be the cloud computing architecture is a well known architecture having front and back end. With the help of the cloud computing architecture, we can perform various tasks remotely. So another one is cloud architectural layers. So here layer in the sense service models. Layers in the sense service models. Cloud architecture layers are cloud architectural service. So there are three defined well-known cloud architectural layers or services are providing the cloud computing, namely IaaS, PaaS, and SaaS. That stands for infrastructure as a service, platform as a service, or software as a service, or another name is application as a service. So these three are well familiar cloud computing layer architecture or cloud computing service architectures. So these three development layers are implemented with virtualization and standardization of hardware and software resources provided in the cloud computing technique. You consider the infrastructure layer or infrastructure model, the servers as the foundation for building the platform layer of the cloud for supporting platform as a services here. So in the infrastructure layer, so it can have various infrastructure components like servers, like virtual machines and storage devices, network components. These are considered as a infrastructure as a services. So coming to the point, another layer is platform layer. The platform layer is the foundation for implementing the cloud application layer with the help of software as a service applications. Whenever you want to run your application over the cloud, you need a platform. So that platform can be provided by a cloud provider. You consider the infrastructure layer, it is having virtualized computing like storage devices, network resources, and proper utilization of the resources provide the flexibility demand based on the end users. So whereas the platform layer, it provides an environment providing the development, testing, deployment, and monitoring of the usage of an app. Suppose if you have an app, if you want to develop the app, if you want to test the app, if you want to deploy the app, or if you want to monitor the app, you need one platform, you need one environment. So that environment will be providing by the cloud computing technique. So indirectly the virtualized cloud platform act as the middleware. It can be placed between the infrastructure and application layer of the cloud. So next we talk about application layer. Application layer is nothing but software layer. So it is formed with a collection of different modules of the softwares that are needed for set up the software as a service applications. So the general service applications include those of information retrieval, document processing, and authentication services. So this layer is used for CRM, financial transactions, and supply chain management. That means that all software as a service related actions can be done within this layer. If you consider the architectural development of cloud platform in a layered architecture, like architectural development of cloud platform can contain some cloud layered layers, like three different layers or three different models. Infrastructure as a service, platform as a service, and software as a service. These are well connected to the cloud deployment models like public cloud, private cloud, and hybrid cloud. These public cloud, private cloud, hybrid clouds will be kept in one environment that is called as the internet. So provisionally, both private, physical, and virtualization cloud resources can provide the connectivity between the services as well as a deployment models. You consider the infrastructure layer, the model of the infrastructure layer here, IaaS. It is built with virtualized computing like storage and network resources, and it is connected to the platform layer. The platform layer provides the end users with an environment to develop or to monitor or to test their applications. If you want to they deploy or monitor execution results and performance over the cloud. So whereas the application layer is also formed with a collection of all needed software modules of software as a service applications. All these are well connected to the virtualized cloud resources. So in the virtualized cloud resources, it can connect it to various cloud deployment models like public cloud, private cloud, and hybrid cloud. So based on the requirement, they can host the data and they can perform the data. So very easily. So now next we talk about cloud architectural layers, how these demand, which one is high, is having highest demand, which one is having moderate demand, and which one is having least amount demand. We will talk about. If you consider these three cloud architectural layers like software as a service, platform as a service, and IaaS as a service, there is huge demand for utilization of cloud services like software as a services, and there is a moderate demand of platform as a service and a least demand for infrastructure as a services here. So next we talk about the market oriented cloud architecture. So the market-oriented cloud architecture will be automatically scale down or scale up their activities based on the on-demand customer requirements. So that's why we can consider this one as a market-oriented cloud architecture. So consider the diagram here, the market-oriented cloud architecture to expand or shrink leasing of resources with variations in quality of the services or demands from the users. That means that the structure of cloud computing may vary very frequently based on the on demand of the customer requests. Sometimes it may scale up or scale down automatically so to fulfill the customer requirements. That's why we can consider this one as a market oriented cloud architecture. So the market oriented cloud architecture, so if you observe here, end users on the topmost parts, the end users are there. The duty of end user is, their task is the end user submit a service request from anywhere in the world to the data centers. They simply submit one request to the data centers and the cloud to be processed that request. So with the help of the internet only. So here SLA resource allocator, SLA stands for service level agreement resource allocator. He acts as the interface between the data center and is as a cloud service provider and external users. It can be acted as a interface between data center, cloud data center, and cloud service providers. So when the service request first submitted by the end users, the service request examiner, here the service request examiners are there. The service request examiners will receive the request, interpret the submitted request for quality of service requirements before determining whether to accept or reject the request. So once the end user send the request to the data center, in the data center, the service request examiner will receive the request and they can finally verify or determine that whether to accept or reject the request based on the need only. So when the request is accepted, it can be moved to the pricing mechanism. Here, the pricing mechanism decides how service requests are changed. For instance, requests can be charged based on the submission of time or peak time. That means that the request is to be submitted. They can observe that whether it is a peak time or off time. The end user submitted the request as a peak time or off time. So based on the peak time and half peak time, they can charge they can impose the amount to the customer. So how much they have to pay and when they have to pay. So next here, once the price mechanism was fixed, then move to another one is accounting section. Here the accounting mechanism maintains the actual usage of resources by the request uh, so that the final cost can be computed and charged to the end users with the help of the accounting. So next, the virtual machine monitor, VM monitor. So this virtual machine VM monitor mechanism keeps track of the availability of all virtual machines and their resources over the client machines. So next, we talk about another mechanism that is called as a dispatcher mechanism. The dispatcher mechanism starts the execution of accepted software requests on allocated virtual machines, whereas the service request monitor keeps track of execution progress of several service requests over a period of time. So here, if you in the bottom, if you consider, there are multiple virtual machines. These are well connected and kept in a cluster that can be concurrently run the applications based on different operating system environments on a single physical machine, since the virtual machines are stored or isolated from one machine to another machine on a sample physical machine. So if you consider the quality of service factors, so QoS, how the QoS will impact on the cloud computing the architecture is the critical QoS parameter is to be considered in several cloud requests such as the time and the cost, reliability and trust or security. So the quality of the services parameters will be mainly focused on these requests. How much time is required, what is the cost they are charging, and how reliable the cloud is, and the security and the trust management impact on the cloud will be mainly depends on the parameter of QoS. So in particular, the QoS parameter cannot be static. It may vary or it may changes very frequently based on the demand of business operations, various operating environments. Here, we can consider in the cloud architecture, we can consider one important factor that is called the virtualization of a software that is used the platform for developing a new cloud applications that enables developers to use any operating systems and programming environments they what they like and where they like it. So next we talk about virtualization support in public cloud. So, in the sense, virtualization, in the sense, it can provide an environment for virtualized cloud. And so, with if you want to run a big or large amount of data over the cloud to overcome the problem, instead of maintaining or processing the data in a single computer, you can take the help of the virtualization concept. Virtualization concept will improve the capacity of the cloud by adding the servers by improving the networks over the period of time. So here, some of the very familiar public clouds which can support for virtualization in the market listed here. There are three public clouds in the virtualization supports. The first one is AWS, stands for Amazon Web Services. This is one of the familiar cloud virtualization support. Another one is Microsoft Azure Cloud, and the last one is GAE, Google App Engine. So these three are well noted or well familiar public cloud virtualization support models. Few details. Consider the first one is AWS, stands for AWS stands for Amazon Web Services provides flexibility to the virtual machines for users to execute their own applications. It provides so the based on the customer requirement only, it can give the flexibility to the end users for executing their applications over the cloud AWS. So based on the customer needs, they can provide, they can change the configuration of the system, they can provide the increase or decrease the networking as well as the service providers. So another one is GAE, Google App Engine. This Google App Engine provides limited application level virtualizations. That means it is not full-fledged virtualization concept like AWS. It is very flexible virtual machine, whereas Google App Engine is not flexible virtual machine. It is very limited application level virtualizations which can be provided to the end users to build the applications based on the services that are carried by the Google. There are various limitations for utilization of virtualization concepts in using Google App Engine. So coming to the next one is Microsoft. The Microsoft is also another cloud service provider, namely Microsoft Azure, which can provide the programming level virtualization like .NET virtualization, and which can be used for users to build their own applications over the period of time. So another tool is the VMware. The VMware tool apply to the workstations, servers, or client machines or virtual infrastructure to perform some tasks. So whereas the Microsoft tools, some of the tools are used on personal computers and some special servers they are used, whereas the IBM, whereas the Xeon, Intel Xeon Enterprise tool applies to only Xeon based servers. So it seems to be the virtualization support can be very effectively applied in various cloud service providers like in the market, AWS, Amazon Web Services, GAE, Google App Engine, and Microsoft Azure Clouds. So some of the challenges will be in our front to overcome the challenges, what to do. So these challenges will be play a vital role in the cloud architectural design. So while designing the cloud architecture, there are various challenges we have to face. So there are six open challenges in cloud computing architectural development. The first one is data service availability and data lock. So service availability and data lock-in problem. So whenever the data, bulk data is available in the cloud, if you want to lock the data over the cloud in particular sector, so it is very difficult for providing the availability to the end users. That is one of the challenge for that one. And another one is always the architectural design of the cloud computing will struggle a lot for providing security and privacy for the cloud, like the data which was hosted, the end users can host their data, own data or sensitive data over the cloud with the help of the internet. The data can be sensitive data, cannot be corrupted, cannot be modified, or cannot be destroyed. So for providing the security for the data, it is also one of the open challenge for cloud providers. And another one is unpredictable performance and bottleneck. So there is a small bottleneck or unpredictable performance. That means that the performance of the cloud computing cannot be predictable, and it can be unpredictable over a period of time with the help of the cloud computing technique. This is also another challenge nowadays. And another one is distributed storage and widespread bugs. So distributed storage means we can keep various data centers in different remote locations, and we can having some problems whenever some problems will rise to rectify the bugs using widespread. That is another challenge. That means that the bugs identification and the bugs clearance can be a challenge task in a remote locations or remote places hosted maintained data servers. Another one is cloud scalability, interoperability, and standardization. So that means that based on the on-demand services, the on-demand requirement, the clouds may be scale up or scale down their services by adding the resources like by adding the servers or by adding the networks so over the period of time to rectify the problem, to fulfill the demand and supply. So interoperability and standardization, these are also challenges, well-known challenges nowadays in the market. So another one is software licensing. Software licensing is nothing but nowadays the usage of software is very high, and very frequently the updations or the new technologies or emerging technologies came into the picture. So due to which we need to maintain, our cloud service providers will maintain or upgrade their data centers. So very soon, based on the requirement of the customers, whenever a new software enters into the market, automatically the cloud service providers will upgrade their existing software, or they need to grab the new software which was entered into the market. So for providing very effective services to the end users. To consider the service availability and data logging the problem, all the cloud services and functionals under a single company, that itself may be the reason of failure of the cloud. That means that data locking a problem. So data lock in a problem when it will arise is if we can keep the data in a particular single server or single cloud. If due to any reason that cloud will fail you, the services are functioning under a single cloud may be stopped. To work on the problem, we suggested that design the architecture of the cloud in a remote manner, with a different, not centralized, go for the distributed manner. So that is the one of the drawback in cloud design architecture. To achieve high availability, it is advisable to use different services from multiple companies. So that means that we can keep or maintain the virtual machines or data centers in different virtual locations or different on-premises locations. So that is one of the best solution for providing the architectural design of the cloud computing technology. Another one is the unpredictable performance and bottleneck. That means that the multiple virtual machines can share the same CPU or main memory in the cloud computing technique, but the input output sharing is difficult and very easily to overcome the problem. So a best solution is we can migrate and we must try to improve our input output architecture and operating system to virtualize the input output channels. So finally, we can conclude that clouds and data bottlenecks must be removed or widened to obtain very efficient, highly availability technology. So another challenge for architectural design of a cloud is database usage. Nowadays, the usage of database is very dramatically grown in the cloud computing, and all it cannot be stored in a single place. So that's why instead of keeping the entire data in a single machine, we recommend to place the data in a different remote locations. So for that, we need to select distributed storage came into the picture, but also brings network problem like efficient storage area network is required whenever to if you want to access the data over the period of time with the help of the distributed storage networks. So here the problem is maintaining SAM. Storage area network is very one of the challenge tasks whenever we are working with the distributed storage cloud computing techniques. So we use frequently simulators is another way for understanding the problems and propose a satisfactory solutions for utilization of services over the period. So these are various topics we discussed in this session nowadays. So in this session, we mainly focused on the architecture of the cloud computing and the goals of cloud computing technique. What are various cloud computing architectural layers in the sense architectural models, cloud computing models like infrastructure, platform, and software, and we talk about different cloud service providers which are available in the market. Those architectures also we discussed like Amazon Web Services and Microsoft Azure Cloud and another few clouds we discussed in this today's class. So we came to the end of the session. Now I am starting the class. Thank you.